This is a very high-level sort of energy optimization related discussion. Now we will move to module 2, which is typically on HOMER. Now the HOMER session starts now. So what we will do now is we will show you, we'll talk about what is HOMER, and then we'll show you how to download the HOMER and how to install it, and then we'll walk you through on how to get the data installed, how to get the data input to the commute, identify the best results. Now, very briefly, HOMER is it's a simulation tool. It's a software that gives you a very good way of creating dimension of your green solution. This is one of the tools that can consider any of the solution: DG, battery, hybrid, grid, battery, DG, hybrid, fuel cell, biomass, CNG based generation, wind turbine, PV, flow battery, you name it. You can actually incorporate all these solutions into HOMER. Now today we will walk you through with one of the sample model, and then if you have any more sort of if you want to go for any complex model, you can definitely do that, but if the time allows. If time doesn't allow, we can take it offline definitely. This tool is developed by National Renewable Energy Lab, NREL, which is a division of United States Department of Energy. This is actually a tool developed through a few years back in last decade, and it came into public earlier this 2007. And then from 2009, this is quite getting traction in the market, and we started using HOMER from 2009. In GSMA. There is no connection between GSMA and HOMER, and we're not actually promoting HOMER, rather we're actually promoting one single tool that we think is quite useful for telecom. Now HOMER can be utilized for any industry, telecom, household, I mean megawatt level power production, anything, anywhere you can actually utilize this tool. And this tool is available, this software is available in 2 versions. One is free, one other is paid. So the free version and the paid version is both are available at the same location, same website. We will show you the free version, which is called HOMER Legacy version. And the difference between HOMER Legacy and the paid version, it's on the functionality level. Like especially once you go for the outcome, there are a few of the areas where the paid version is described a little bit detailed. But if you look at it in a pretty much typical telecom points of view, the free version is quite workable. So we don't, I mean, initially once you start using it, we don't recommend you to go for the paid version. You start using for the legacy version, and if you think that this is one of the tools that you want to use for long term, you can go for the paid version. Okay. So we'll not talk about this. Just a quick one. So usually what happens is, especially for wind solution and solar solution. Now this is the solution where you need to depend on natural resources, and getting the source of natural resources is quite critical. We discussed yesterday about the wind resource. We had a long chat about the wind solutions feasibility yesterday, and we talked about where we can get the wind data. Now while doing this training, we will look at the solar data from the NASA database. Now the beauty of HOMER is HOMER is directly connected to the NASA database for the solar radiation data. So if you put the latitude and longitude and the time zone, then HOMER automatically pulls the data from the NASA database. It's for solar, not for the wind. Now for the wind, NASA also has a database for wind average data. But the challenge with the data is it's an average data. You don't actually get sort of specific current wind situation snapshot. It doesn't give. So it gives you a very generate, that's 20 years average wind speed result, and that may give you a good sort of sign whether or not this can be a good one for telecom side wind turbine installation. But I mean, but it can give you a generic idea whether you can consider or not. And then once you really want to install wind turbine, you have to go to local Met Office in other wind mapping areas and see where we can get the detailed data. 3TIRE is one of the solutions, one of the website. They have a product called First Look, and you can get generic sort of wind speed related visual data from their first look of 3 tiers website. Now, what you do is you go to homerenergy.com and you can download the HOMER. Now, I will quickly go to that website and I will show where you can get it.
Some of them are carrying the laptops. You can use.
Yeah, if you're carrying a laptop and if you want to try with me, you're welcome. So what you have to do is you have to go to homerenergy.com and you have to look at the software section, which is on top of the website, and go to the download. So once you go to download of the software section, click that. Eventually it will redirect to the next page where there's a big button called download. So you click the download button, it will automatically redirect you a registration page. So the registration is for user to track. So usually what you have to do is, if you're an existing user, put your username and password. If you're not an existing user, go for registration. It's a simple like your name and email address, that's it. And then automatically once you do the registration complete, it will go to the download section. And then from the entire download list, what you have to do is you have to go down on the website and there's a tab called HOMER Legacy 2.68 and download the HOMER Legacy version. So yes, right there, right there. Okay.
Software.
Yes, yes, software, download,
And then
download. Okay, click on the download. Okay, so existing user or new user. So if you're an existing user, press that. If it is a new user, press the bottom one. So yes, you can use your Chitish. Okay, log in and then go down. So in the upper side of this, there is a free trial version for the paid version, but we will work on the go down. There you go, the HOMER Legacy, free. Download that. So in this particular site, you actually have some sample sites, so sample files which are available, like HOMER Legacy. Sorry, sample data files for HOMER. Look at that. Yes. So you can actually download some of the sample files, which can be good for you to just look at, play around. Okay, so once you are done, so you have to download individually, because the exe file, once, let's say you download it and you wanted to share with your friends and colleagues, it doesn't work. So you have to download individually and install it. So yeah, that's about installation, and then double click, installation done, complete, and then we'll move on to the next bit now. So once your installation is done, you double click on the HOMER, it will be like this. So it's a very generic, simple, humble tool. There's nothing fancy about HOMER. Since it's a simulation tool, it will ask you a lot of questions, because the way HOMER works is it takes all the different inputs and it tries to create a good number of combinations based on cost of energy, power generation. And it creates a list of solution from lower cost of power generation to higher cost of power generation. And so if you ask HOMER, it will actually, it is not a tool which can, a lot of cases actually operator ask me, can I get any tool where I'll just put my power load and it will automatically give me a dimension, what solution, what dimension. I said, yes, that's probably possible. Then it has to be connected with your brain, is because you have to really know about the site situation, because there is no way a software can identify the site situation. Load, from one single load, there can be hundreds of solutions. If it is a 1 kilowatt or 2 kilowatt load, you can get hundreds of solutions, right? But how the tool will know what solution will fit well? Because it's not literate about the situation on the ground. It's not literate about other circumstances. So on and so forth. So you have to put a lot of inputs in HOMER. So it's a little bit boring of inputting all the data, but once you do it once, and once you start using it, it's one of the finest tools for green solution dimension. And once you did it once, next time it's easier for you, because next time you don't have to input all the data. It's already there. You just have to edit some of the data. That's it. So what we will do is we will take some case, we will take some sample case, and we will do those sample cases. So what we have taken as an example is we have taken as an example of a sample site. Let's consider 1 kilowatt outdoor site. Let's go on a simple site, simple characteristics of site, and then we can continue doing for a higher load site, indoor site. We can do for grid connected site, which is poor grid available. We can go for solar. We'll start with solar, and then we can go for solar DG hybrid. We can go for wind turbine solar DG hybrid. We can go for anything that you say. We can even go for only DG plus battery hybrid without having any solar or wind turbines. We can do all these different sort of combinations. But it's going to take about 3 days in order to go for in order to walk you through all these things. So what we'll do is today, in next only few hours, is we'll go for one or two simple models. So we'll do 1 kilowatt with outdoor sites, and then we'll do 1 kilowatt, let's say, or maybe 2 kilowatt grid connected or poor grid site. We can do it outdoor. We can also do an indoor if time permits. And then if you have more questions, we can take it offline, and we can create more sort of models. We have tons of models created in our pocket, in our computer, so we can walk you through lots of those. Okay, so 1 kilowatt outdoor site. So what do you start with? So there are 6 different steps in order for creating good models in HOMER. So first step is to select the equipments. So what we do here is click the Add Remove button, and you'll see this load components. These are the two area here. Loads is the loads that you have to select and describe, and the components is the components that you have to select in order for HOMER to do the simulation. Now the question is, do we know what are the components to pick? Now this comes with an experience. So if you're a first-time user, it's difficult for you to identify. But if you think that I'm not sure what solution to pick, you can pick all. And let HOMER decide. You can actually do that. And then HOMER will pick the best solution for you eventually. Now, what we'll do is to simplify the whole thing, we plan to create, let's say, 1 kilowatt outdoor site with a solar. Let's do that. And let's consider that we don't want to go for pure solar. Rather, we want to go for a DG hybrid solar. Okay, let's do that as a sample. Okay, so what we need to do is we need to have a load. That means the power required at the site. From the component, we said we want to create a solar. So we'll put PV. And we said we want to create a hybrid solution with a diesel generator. And eventually we need a battery, because without a battery, it doesn't work. Battery. Now, since most cases, if it is a DC-based diesel genset, then it's fine. Then PV is also DC, generator is also DC. But if you're planning to have, let's say, a AC-based diesel genset, and then PV is DC, then you actually have to have a rectifier in order for your battery to store the power, get the power from the genset and store it in the battery. So you have to have a rectifier. So you have to put a converter, which is actually a rectifier. So one of the beauty of HOMER is once you put your insertion point to enter the components, it actually explains you what is that. So let's consider you're not sure what is that. Just put your insertion point here. It will actually talk. A converter converts electricity from DC to AC or vice versa. So so you need a converter. Done. For the simple sample or examples, the selection is done. Now look at the bottom part of it. It's called grid. Now there's 3 situations here. Do not model grid. System is connected to grid. Compare standalone system to grid extension. Remember there was a topic earlier we discussed whether we extend the grid or not. Okay, so this actually connects with that. So do not model grid means it's a standalone solution, and you're not going to create anything with grid connected. Second system is grid connected. And the system is grid connected means a system is grid connected and is actually producing power for the grid. So it's actually, the second option is not for you. It's for the grid power producer. The system is grid connected means it's producing power and feeding it to the main grid. Third option, it can be for you, applicable for you, which is whether you want to compare the grid extension cost versus the standalone solution cost. So what we will do is we'll start with do not model grid, which is the very simple, sort of way of looking at the first sort of examples. So we will click on the do not model. Okay. Now, let's start from a new one, because it's usually this shouldn't be, the arrow shouldn't be there. So what I will do is I will just create a new template. Now look at, so all the components is kind of detached. So we have AC row, we have DC, AC column and DC column, and all the components are separated. Now what we need to do, what we'll do is we have to go and configure individual components, and then once the configuration is done, you will see an arrow connected with the lines, with the columns. Now what we have to do as a second step is go and configure individual components. A little bit boring, but stay with me. We'll have a coffee break once this configuration is done, so that we can have a little bit of refreshment. Okay? Okay. So we'll start with the primary load. Now, HOMER is good. HOMER is actually very good. Now, why I'm saying so? Because it actually captures all of your real load requirement. Now, the primary load in this tab, in this window, you actually can configure your load requirement. Now, let's consider that your load requirement is different in different part of the day. For example, your peak hour from 10 a.m. to 1 p.m., your load requirement is higher, and the rest of the day, let's say your load requirement is lower. You can actually go for individual hourly load settle. So you can put your load requirement 1 kilowatt here and then 1.5 kilowatt here. So eventually, based on your actual load requirement, you can put your data here. Now, this is a manual way of inputting the data. If you have your data available of an existing load profile of your site, if your NOC has the data already of your existing site load profile, you can actually import the data and put it here. So you can import the data, .dmd file has to be there, and you can import the data. Eventually it's going to be perfect. Now you can eventually put another classification, another sort of ways you can do the classification, which is weekend and weekdays. In many occasions, maybe your weekend and weekdays power requirement is different, and in different part of the month. So let's say your Jan's requirement is different from May, you can actually do that too. Now, now we will do with a simple one. So we'll start with 1 kilowatt generic for all of your hours to make our first example easy. Now what we'll start with doing is we'll level it. So let's say this is your site load. Load type, most of the cases the telecom equipment is a DC load. Remember, it's an outdoor 1 kilowatt site as an example that we're taking. Okay, so one DC load. Let's stick to this starting from Jan to onward rest of the 12 months, and then this is weekdays. Let's consider as a generic one. Okay, let's consider 1 kilowatt throughout the day. 1. All right. Now look at this random variability. The random variability is, do you have any sort of variation that exists in your power requirement at that site? What does it mean is, let's say for some reason your day to day there is a variability exists, because today this site is located in a marketplace, and the market happens in every alternative day. So during the market day, your TRX utilization goes higher, because a lot of people actually come to the location, and your power consumption goes higher. So let's say it happens in every alternative day. So you're actually having a different sort of load profile, or maybe a little bit of variable exists in the site load requirement. Now, if we have a generally specific data, it's good, you can put it. If you don't have any specific data, what we suggest always is maybe you can go for a 5% variability. Is it 5% from day to day, or time step to time step? Time step to time step means 1 to 2 p.m. and 2 to 3 p.m. The two different time slots have a 5% variance of power requirement. So this is actually a very sort of generic recommendation, 5%, but if you have any specific understanding of load profile, you can go for that. So what we'll do here, we'll go for 5%. Done. So we now have entered all the load requirements. Perfect. So we'll do what? We'll do press this OK button. So this load specification is done. Now we now have to look at the power generation specification. Now in this case we have two power generating component. One is PV, another is genset, diesel genset. And now it can be a CNG based genset as well. It can be any other sort of gensets, LPG based genset as well. So we consider it as genset, and then let's figure out what sort of fuel we want to put it in. Now for PV, we click here on the same way, click the PV. Now remember, there are one basic principle. So all the equipments that will be, is it clearly visible from the back? It's clearly visible? Okay. So one of the basic theory here is you have to put the unit one, and then you have to put the unit cost. And then third is you have to put the sizes to consider. And all the components that you will select here, there are three components that you have to do for sure, must. I mean, you have to do it correctly. One is unit, number two is the cost, and number three is the sizes to consider. Sizes to consider means, you know, you may actually consider, you may ask HOMER to consider these sizes. It's not necessary that HOMER will consider, it's not necessary that HOMER will consider one of those, but HOMER will consider all of those and bring you the best result. And that's why you can actually suggest HOMER to consider different sizes. It's just to give an option to HOMER to, you know, think kind of like in a wider way. So three things. One is unit, cost, and sizes to consider. And all components that you will keep here, whether it's a PV, DG, battery, every occasions you have to put three different elements. Now size here. Now let's consider this is an existing, okay, this is a new site. Let's consider this is a new site. And this is a PV, and now we have to bring some of the capex value here. Now let's consider in the market we have 250 watt PV modules available. Let's consider it makes our life easier. 250, it's a easy multiplier. Okay, so let's consider that, as I said, unit, always keep it, bear in mind it's unit. So one unit means one piece of PV module. So size, it has to be, what is one piece of PV module looks here, is about 250 watt. If you can convert that to kilowatt, it's 0.25 kilowatt. Okay, this is the size of one panel. Capital cost, any suggestion? Of that one particular PV module, nothing else.
It's around
$1?
Anything else to that?
Shitish, can you check it? The temperature inside is very high. It's hot inside. The air conditioner isn't working. So
around $40.
$400?
400, yeah? 400.
So yeah, the current market price for PV is actually 60 cents. So no, I'm talking about the global, because PV modules is actually works in the same way. Crude oil is sold, gold is sold, platinum is sold. It's the same. It's actually open market, but because of the import duties and a transport cost and all the other accessories cost, the price goes higher. But we're actually counting only on the PV modules. I think a $1.5 to $1.6 something is a good number. We will be in a safer side. Let's say $2 per watt peak. I'll put a $500. Happy? $500. Okay. O&M cost. We can actually have a O&M cost per module, right? It's difficult. You can actually have a O&M cost per module. So what we do is we will take all the O&M cost aside and put it in a fixed OPEX per year cost. The reason why we always suggest, yes?
Sorry for those, the $500 are for
one single module.
Okay.
We haven't included the infrastructure cost, civil works cost. We We haven't considered those, only the PV module cost.
Only the fund.
Yes, the other costs we'll consider later part of this software. Okay, so O&M cost we'll consider 0 here. The reason is we want to consider it's a whole package operation maintenance activities, whether it's done by you or it's done by your partner. And we're considering that it's a yearly package that you are giving to them. So we'll take that yearly fixed O&M cost and we'll place it separately in another option called finance in this HOMER tool. Okay, now remember I said sizes to consider has to be there. What it means is HOMER should be considering all of the different sizes and it should be giving you the optimum results. So what we usually, now there's two elements of here. One is HOMER should be given the opportunity to think and give you the best output, number one. Number two is the practical barrier that you have at the site. That means, let's consider you have issues of site acquisitions and you don't have a space of more than, let's say, 10 meter by 10 meter. And you have a space limitation where you know that you can go up to 16 PV modules. That means here 4 kilowatt. So you can go up to 4 kilowatt of sizes to consider. But if you think that you can actually go up to a larger sort of footprint, you can go further. You can go up to 10 kilowatt, 12 kilowatt. But always bear in mind that there are two things. One is the design is done before you go for the procurement and before you go for the real implementation. Now you have to get real field sort of field data or field feedback whether it's practically possible to acquire more lands. If it is practically possible to acquire more lands, then you go up to 10 kilowatt, 12 kilowatt, no issue. But if you cannot practically procure or acquire more lands, then look for what is the available lands available at the site and how many modules you can literally install there. And based on that, let HOMER to decide what would be the best option for you to come up with your battery bank size, come up with your genset dimension, come up with your rectifier dimensioning, come up with your PV dimensioning. Because it's not about the PV, it's about all the other components all together. If you have all the components having the right size and rightly located, then you have the maximum output. Otherwise, you can't only blame on the PVs or you can't only blame on the batteries. It's all the equipment has to perform really well. Okay, so in this case what we will do is we'll go up to 6 kilowatt. We'll go up to 6 kilowatt. Now we'll start. Now usually what we do is we'll start with giving all the options here listed down. Now the small trick here is, or maybe a cheat code is, you may consider not putting all this, rather start with 2 kilowatt. But once you start using HOMER, maybe it's going to be more familiar for you to, or easier for you to make this thing happen. There you go. So what we did is, in the sizes to consider field, we started like 250 watt, then multiplication of that went till 6 kilowatt. So once you do it once, it should be already there. And next time you do not have to do all these things. Now usually once you become an expert, you'll eventually realize that there is no reason of putting 0.25, 0.5, 0.75. Because eventually this won't generate enough power for you. So eventually you will start with 2 kilowatt. So if you go for starting 2 kilowatt, it should be fine as well. Practical, that should be fine. Okay, now look at this side. Output current, AC or DC. Now if it is an AC, then AC. If it is an DC, then DC. Eventually it's a DC. Lifetime. Now it's a set lifetime of 20 years. Set default value. You can reduce it to 10 years. We never recommend to consider 20 years. I mean, probably manufacturers or vendors will argue with me, but we have done extensive sort of kind of like to understand different solutions. We have been dealing with multiple manufacturers. We have done a lot of extensive joint work with grid power manufacturers, especially with the PV-based mainstream megawatt level. And we realized for the fact that the efficiency degradation is not bad actually. It's quite like about 1% per year. The efficiency reduces for PV start from about third year. So third year onward, the efficiency reduces for 1% every year. So eventually, we consider that once you're making a business case, let's do it for 10 years, because eventually you won't be having 20 years PV installed on a site, because you never know what's going to happen in 20 years in the telecom industry. Derating factors and all these things, I mean, derating factors 80% is a standard value unless you are in a place, desert, or in an island, or in middle of Siberia, where lots of tons of snows out there. So I think 80% is a standard value that can keep to. If you have a specific reason of changing it, definitely can do it. As I said, desert, an island country, middle of ice places like Siberia or pole, North and South Pole, probably it's a different factor we can consider. Slope, degree, and azimuth, it will count automatically. Once I put the latitude and longitude, it will automatically bring the value here. So no need to touch anything. I'm not going to discuss the tracking system. Ask me why. Because probably telecom, we're not interested for tracking. I mean, it's tracking the sunshine and tracking your. I mean, definitely. I mean, we know for sure that some of the places like Mongolia, the tracking system can be really perfect, because 6 months of the year, your PV has to be in this side. 6 months of the year, the PV has to be in this side. It's entirely opposite. So every 6 months, they have to deploy their resource, and they have to realign the PV. Otherwise, they don't get a power. It's 100% shading that happens every 6 months. So maybe the tracking system can be very perfect for those sort of situations, but tracking is very expensive. I know some of the manufacturers are really optimizing the cost for tracking device installation. I think in the next 5 or 10 years, maybe once I get it in a cheaper, very cheaper price and a very small footprint. And once you go for installing the tracking, you need to have a bigger footprint as well. I mean, you need to have a more space. So it's going to be difficult. So let's see. We're not recommending to install tracking system at telecom sites, but maybe in future, if we can get a more efficient solution, we definitely will recommend. Now, as I said, this is one of the power generation solution. Now, once we have done the configuration, it's now connected with the arrow. Now we have the secondary power generation, which is diesel. Now we have to configure that, and then we'll configure the battery, we'll configure the converter, then we'll go for a coffee break. Okay, again, unit, price, charges to consider, same thing. Unit is a size of the equipment, it's a unit size. So now if it is a new site, let's say a newly constructed site, so you haven't really have any existing genset, then you can propose a genset site. If it is an existing site, we always recommend to use or utilize the existing genset, and HOMER will actually suggest you what will be the best way of utilizing the existing genset, and a very lower number of operating hours. So if it is if it's a new site, then definitely would recommend you to go for a smaller dimension diesel generators. Instead of going for 20 or 30 kVAs, maybe you can go for 8 kVAs, 10 kVAs, I mean, whichever comes easy for you. But now remember, if the genset is not enough, HOMER will tell you that, look, the genset that you suggested for dimensioning the site is not enough. So increase the size of a genset. So HOMER will tell you actually. So let's say if you want to do a trial and error, kind of like a playing stuff, you can actually do it. You can go for 4 kVA, which is literally not available, but you can go for 4 kVA and see whether HOMER can actually cope up with 4 kVA or not. And if HOMER thinks 4 kVA is 4 kilowatt is enough, then it's enough. If it thinks it's not enough, then it will automatically ask you to increase the capacity of your genset or increase the number of genset. So it will actually ask you. So to make the whole thing simpler, what we'll do is we'll go for like about 10 kVA, which is 8 kilowatt system, maybe. Can you do that? Mm-hmm. Okay, okay. Capital cost? Stephen? Approximate cost.
Duties included?
Yes, landed cost. $3,000? It's cheaper than India?
10.
Oh, everything included, transport duties.
10 is 20.
No, it's a 10 kVA, which is 8 kilowatt. It's a 10 kVA. So 10 kVA. So
The cost of a 20 kVA landed here is about $10,000.
$10,000. So the cost for 10 kVA would be something about then, you know, maybe around $7,000. It's not linear. So the cost difference is not linear. So maybe about $7,500 maybe. Yeah. So you can take that right. Yeah. Yeah, $7,500. Okay. Just take it. Replacement cost, replacing the same. I mean, definitely once you go for a real business case preparation, take the inflation and take those, consider all those other values and take the replacement cost. Now, replacement cost has to be considered very efficiently if you go for a DG battery hybrid solution, because in that case, it actually looks at the replacement cost, overall replacement cost in the whole business case. So HOMER brings you a very nice, interesting 10 years or 5 years sort of business case. So once you go for a DG battery solution, make sure the replacement cost is carefully handled. So when M cost per hour, so this is something that we have to put it here, because now there is two things. One is, in many occasions we have seen that the diesel genset operation maintenance cost is actually separated from the regular site maintenance cost. It's simply because it maybe requires more maintenance, and maybe the maintenance is provided by the diesel genset manufacturers or the local suppliers. So a small question is, what is the approximate when cost for diesel genset maintenance per hour here? Approximate per hour maintenance. I mean, it's run hour maintenance. Should I bring some examples?
The cost of diesel?
No, only the maintenance, not the diesel. Should I bring some examples?
Add oil and do some maintenance for divergent return.
Right, yeah, let's take it in this way. Let's consider that the diesel genset is scheduled to operate for about 12,000 hours. And for 12,000 hours lifespan, how much money you have to put for maintaining the diesel genset, and divide that by 12,000, and gives you a value of per hour maintenance cost. To give an examples, in Latin America, some of the cases of good friends from Movista, the cost is as high as $3. We have seen the same sort of cost structure some places in Central Africa, Sudan, Central African Republic, so on and so forth, as high as $2.5 per hour. We have seen a different sort of cost associated with this in Middle East, as low as about 25 cents. We have seen a different sort of cost in Southeast Asia, like in Indonesia, 45 cents to 55 cents. In India, about 25 to 35 cents. So, you know, so it clearly indicates that something close to 50 cents is a standard sort of value that you actually spend on a run hour basis for diesel genset maintenance. I think we'll go with 50 cents, just to make the whole thing simpler. Okay?
Yeah.
Okay. So sizes to consider. So do you want to consider no, that means 0 or 8? Or do you want to really consider another piece of diesel genset? You can actually consider another piece of diesel genset, but at the same time, bear in mind, let's consider that you're not sure whether 8 kilowatt would be the right choice or 12 kilowatt would be the right choice. What you can definitely do is here, see, put it 8 kilowatt here, you can put a 10 kilowatt, put a 12 kilowatt, 16 kilowatt, 14, 16 kilowatt, put all. And the value changes here on a linear basis, but it doesn't really actually happen in linear. So you can manually change the value. If you think you are unsure about the which size will be perfect, you can actually put all. Like this. Okay. Now look at here, type AC or DC. This is important. Now we know from the market that we have both AC and DC type generator available. In African market, DC type is not probably quite used. we know that in Kenya some of the DC type generator installed, and they were performing quite well, but the DC type generator doesn't get much traction here. So we will take the AC genset, which is the regular one. We will change the name of the genset description. Maybe it's just a DG. That's it. Lifetime operation as 15,000 hours is something has been set here, but you can change it. If you think that your genset can have a run hours, maybe 12,000 hours, then you go for major overhauling, you can do that. Or if you want to, make it like 20,000, many occasions I've seen make it 20,000. So and then go for major overhauling. And then remember, bear in mind that the diesel genset starts reducing its efficiency after 6,000 hours. So after 6,000 hours of operating, the diesel genset will actually the efficiency level will go down quite dramatically. So so you probably have to go for a major overhauling in 10,000 hours or 12,000 hours, and then you can operate that overhaul engine for about another 6,000 hours, and then you have to replace it. Now it actually depends on operator strategy, but this is what the trend that we have seen in many other operators in different part of the world. So yeah, but up to you guys. So I'm just putting 12,000 hours. Now minimum load ratio 30% is quite common. So it's actually 30%, most of the cases. Nowadays there are some more efficient genset are coming, but that eventually is not even, that's eventually after having the efficiency, it's about 25%. So the genset that you usually see on the market, that usually use 30% is the minimum load ratio, most cases. Okay. So we are done with two power generation configuration. Now we have to do with converter and battery. Now we'll go with battery first, and then we'll go to converter. Now the beauty of batteries, once you click it, you actually see a list of batteries here. Now some of the batteries were with HOMER. When you install it, automatically it pulled the data, and some of the battery was we created the data. What you can actually do is, if your desired battery is listed here, great. If it is not, what you can do is you can go for a new and create a battery by yourself. Now how you do that? So let's take an example. So let's consider you want to understand a little bit detail about this battery. Go for detail. It gives you all the values about these batteries. Now these values were derived from or collected from the manufacturers based on the data that was provided by them. We input this value here, or we got the detail here. Now the same way you can create a new one. Let's consider you want to create a new battery, your own battery. Maybe it's a ABC battery. You have to collect all this detail from your battery manufacturers, put it here, done. Okay, done. Now remember, this data has to be authentic and has to be perfect. Otherwise, what happens? I remember a couple of years ago, one of the operators came back to us and said, "Hey, HOMER is not performing well." Why? Because it's saying the battery not to be replaced in 12 years. I said, how come that is possible? Then when we were re-auditing or re-evaluating the HOMER file, we realized that the data input in the battery was wrong. Because of that, the battery is considered as a super sort of efficient battery. Even after 4,000 cycles, it's showing that the lifetime still exists about 80%. Because of that, it's not asking for any replacement. So it's not a mistake of HOMER. It's a mistake of you or us who are actually putting the data. Now you can create your own battery, or you can pull it from the list here. So for the sample case, what we'll do is we'll go with the HOPEK battery. Let's start with HOPEK 600 ampere hour. This one. So the nominal voltage 2 volt, 600H battery. You can click the details to get the details, and then the all same formulas: unit, cost, sizes to consider. So unit here is so to start with the quantity. So quantity is a piece, like one piece of battery that you have to put here, because the detailed specification is already given in the back end. You don't have to give a detailed battery specification. You have to only quantify it. So what you do is quantity 1, and then price for one piece of battery. What you do is, if it is a 2 volt battery, that means you know the one string of battery cost, let's say $10,000, then you just divide it by 24. then you get a one piece of battery. So we need to get a one piece of battery price here. Any idea for 600H deep cycle battery?
$200.
$200 is landing cost, is just a FOB price.
600.
What's the taxation here?
On batteries, no, it is only 18% VAT.
Okay, that's a small one. So I think.
On deep cycle batteries.
Mm-hmm.
Yeah. You will not understand
We
batteries.
go for OPZS technology.
Yes.
That's what require maintenance.
No, but we just took it like a random choice. I mean, there was no thought behind it. I mean, you can pull any other batteries if you want to. We just bring in some examples. That's it. Yeah. But if you want to do some more examples with other batteries, we can definitely do that. But you just pulled it. Yeah. So let's take a very random values like about $400. Let's take $400. Just as a plain figure. Replacement cost, 1M cost, so power battery 1M cost is quite difficult to identify. So we'll eventually put a 0 here, and then as a site 1M cost, we put a separate sort of value for that, site yearly fixed 1M cost, okay? Now this is one piece of battery. Now look at the advanced part, batteries per string. So in this case, you'll have 24 pieces of battery per string, right? Correct? Okay, so we'll just put 24 here. There was put only one, make the value to 24. That's it. Done. So what we'll do is we need to do the sizes to consider this part. So whether it's a 1 string, 2 string, 3 string, let's go up to 2 string. Let's see how HOMER performs. Now, once we hit the OK button, we're done with the battery configuration as well, which is good. So we are left with converter. Converter is very simple, so we'll click on the converter and we'll just do the inputs. So here, just bear in mind that converter, it's two things. One is the cabinet, another is the module. Just look at the rectifier point of view. You have the rectifier rack, and then you have the module. And it's a modular thing, so you actually can increase, if you have the capacity, you can increase or decrease the capacity of the rectifier. So what we will do here, we'll only take the modules cost here, and the box cost, that means the cabinet cost of the rectifier, we'll take it separate. And we'll put it as an additional capex cost. Otherwise, HOMER is a bit naughty here. It takes a linear value which is not actual, actually, which may not be suitable for our overall calculation. So usually, what is a module's size that you use most cases? 2 kilowatt. Okay, 2 kilowatt. Cost, approximate capital cost.
$250.
$250? Yeah. Put a 0 here. Okay, so let's consider. Most cases it goes up to 8. Okay, 16. Okay, so we'll go for 16. Now, bear in mind that this doesn't work in this way sometimes. Sometimes it depends on your genset. Where is it a 2-phase or 3-phase genset? If it's a 3-phase genset, then rectifier usually, you have to have the way you have to create. Yes, the number changes. So you have to bear this technicality back in your mind while inputting the data here. Okay. Okay. So lifetime electronics, in no case I would suggest you to 15 years. Rather go for 8 to maximum 10 years. Any electronics while doing the business case, because you never know what's going to happen. Efficiency, if the Delta guys is here 97%, some other guys maybe have a different percent, but overall the industry is now having very high efficient rectifiers. 95% is something that most cases you actually can get it from the rectifiers manufacturers. Maybe some other guys will say 99%, but I'll probably differ with them. No. So we'll take about 96%. Okay, just the value. Okay. Okay, we're done. This part is actually for inverter. So if you're actually going opposite, let's say for DC to SC, then you look at the bottom part of it. If you're not looking at the inversion part of it, then just ignore it. Okay, done. So we are done. We are done with inputting all the values. So we input the value for the power requirement, power generation, and the conversion, which is converter. So what we'll do is we'll take a quick 15 minutes coffee break now, and then at 4 o'clock we'll come back, and then we will look at the resource section, commute section, which is calculate section, which is the most important one, and look at the list of results, identify which can be the best result to pick, and how to evaluate the results, and then we'll spend about 15-20 minutes on the business case. We created an Excel-based business case, which can be really helpful for you guys. We'll share a copy of that to you as well. So we will walk you through on those areas.